All right, so now that we have some information on how to determine what type of quadrilateral we would have in a coordinate plane, let's talk about another way the SOL will ask the question. It says here, what is the fourth quadrant coordinate that would make this figure a square? And they've given us 3 points to start with. We need to determine what the fourth point's going to be. But let's take a quick look at how our quadrants roll. We start with 1 in the upper right-hand corner, and then we go counterclockwise. We go to 2, 3, and then 4. Counting along the way. That's a 3. Okay. We want the point to be in the fourth quadrant. So the best way to kind of get our head straight, just from an intuitive perspective, I think, is to highlight that fourth quadrant. So go ahead and do that with a highlighter so you know what direction to take. And once you've done that, we've got these 3 points. We know the fourth point is somewhere down here. So we can immediately assume that 2 sides of our square have already been created for us from here to here and here to here. And they've given us EF, D, E, F, so let's assume that fourth point is going to be G. So we'll just go ahead and put a G there. And keep in mind, they've already kind of done a lot of the work for us. By giving us the other 3 points, our goal is to determine what that fourth point is. And since the square is also a parallelogram, the best way to walk through these problems is to just use the slope of the existing line, meaning we're looking for the same slope to be from E to F as it is from D to G if we have our cells indeed a parallelogram. And we can also assume that the distance between the two, if we really truly are just walking it directly up and over on the coordinate plane, would give us exactly what we're looking for. So we could go through some rigorous IC and walk through the slope process, but because in this particular problem they're asking for a specific point, we can just walk it and use the coordinate plane as our tool. So let's look at the slope of EF, because once we can determine what the slope of EF will be, we're going to have the same slope for D to G, and we can use that as our tool to find that point. So from E to F, I'm going to need to go from, let's see here, from E to F. So I'm going to go from E, I'm going to go down 1, 2, 3 places. So that's a -3 for my Y's. Remember that goes in the top. And then we're doing 1, 2, 3, 4 to get over +4 on the x-axis to get to F. So that is the slope of that segment. It's not only the slope of the segment, but it's the actual distance we had to travel down and over to get from E to F. We want to do the same thing from D to G, so let's see here. The slope of DG needs to be exactly the same. Where'd my pen go? Here we go. Slope of DG needs to be -3/4, and so we're going to use the same process. From D, we go 1, 2, 3 down, and 1, 2, 3, 4 over. And that gets us to a G at 2, -2. And let's see here. We'll just finish drawing our square. And it looks like we definitely have a square. Just to get some confirmation that we are in the right here, let's take a look at the slope of, let's see here, DE, the other 2 sides. I don't know why I keep pulling that. And we're going to walk from D to E, so we'll go 1, 2, 3, 4 up, and we're going to go 1, 2, 3 over. So that's positive over to the right, so we're in a positive situation. And then the slope of GF is going to be the same process. 1, 2, 3, 4 up, and then we're going to go 1, 2, 3 over. So we are good. We definitely have a parallelogram on our hands, our opposite slopes. These guys are the opposite segments, and they are definitely the same. These are the same. And if we go to the second step, as we were looking above, we would confirm or look at the adjacent slopes or the adjacent side slopes. We can consider the slope of EF, which is equal to -3/4, and then consider the slope of DE, since those guys are adjacent sides, right? The guys that are kind of touching each other. Whoops, my pen's whacking out on me. And we determined he was 4/3. So if you can see, these guys have a different sign, so they're opposites, and they are flipped. So we definitely have opposite reciprocals. Reciprocal. Oh my goodness. Find my pen again. Okay, opposite reciprocals. So we are living in a rectangle world, We are good there. And then to finally confirm we have a square, we need to look at the adjacent side lengths. So we would do the distance formula from D to E and the distance formula from E to F. And so our D here is at, let's see here, -2, 1, and E is at 1, 5, and F, we can look at F too, that's at 5, 2. So you'd use the distance formula of D to E. We do -2 minus 1 squared plus, let me extend my little line here. Let's see here, 1 minus 5 squared. And we would compare that value to the distance from E to F, right, the adjacent sides. 1 minus 5 squared, the 1 and the 5 here, right, in the x position, and then 5 minus 2 squared. And when you do all that work, you are going to find that these two sides are both equal to 5. So 5 and 5, and so absolutely we have a square or a rhombus. In fact, we've got the square because we already have the perpendicular world going on. All right, so we're going to go to the back of the page now. And we have another example. It's kind of similar. We are going to confirm what point in the second quadrant would ensure the figure is a parallelogram. In addition to confirming a parallelogram, we're also going to do what we just did. Do we have a rectangle? Is this more than just a parallelogram? And is it a rhombus? Or is it a rhombus, right? Of course, if it has both the rectangle and the rhombus requirements, it would be a square like the last figure we talked about. So let's look at our quadrants again. We've got quadrant 1, 2, 3, and 4. And we care about quadrant 2 here. So we're going to highlight quadrant 2 so we know what direction to take. Okay, again, they've given us 3 points to start with. So given the fact that that fourth point, the fourth vertex of this guy, is going to need to be somewhere over here, this is where your intuition needs to come in, we can go ahead and draw a line from L to M and draw a line from M to N. That ensures that that fourth point is going to be somewhere in this area. And we're going to use the same process we did before, and we're going to count off on the slopes. So we'll just kind of start with the slopes of the opposite sides. Again, we're looking for them to be the same. So we'll look at the slope of LM first. And I'm just going to count from M all the way up to the point where I can go over to L. So I'm going to go 1, 2, 3, 4. That's 4 in the Y area. And then I'm going 1, 2, 3, 4, 5 to the left. And if I go left on the x-axis, I'm negative. So this slope is really what, -4/5. Okay, so whatever I did to go from M to L, I need to do the same thing to go from N to our new point, and we're going to call that new point O. So I'm just going to put an O there. So we're going to say here, M, the slope of NO equals 1, 2. Let's see here, 1, 2, 3, 4 up, and then 1, 2, 3, 4, 5 to the left. So our O is over here at 1, 2, 3, 4, 5, 6, 7, 8. We are at 8 and 2. Point O is at 8 and 2. We've got the same slope. We know our opposite side slopes need to be congruent. I'm going to use a different color just to walk through these little numbers I just made. All right, there we go. We can show that. Let me go back to black and finish out our parallelogram. But again, let's take it to another step and confirm if we have a rectangle. And for that, we're going to confirm what the adjacent slopes look like. If they're perpendicular, then we definitely have a rectangle on our hands. So let's look at the slope of M, the slope of LM, which we know to be -4/5. And then let's take a look at the slope of OL and confirm what that is. We'll go from O to L to come up with that. So we're going to go up 1, 2, 3, 4. going up 4 on the y-axis. Let's see, where was I here? 1, 2, 3, 4, 5. All right, so we've got two slopes. One is positive, one is negative, but you can see that they are the same actual number, meaning they haven't flipped. There's no reciprocal. So because these opposite slopes, I'm sorry, these adjacent slopes are not showing a perpendicular relationship, we would say this is not a rectangle. All right. Finally, we want to confirm whether or not we have a rhombus on our hands. And to do that, we need to look at the distance. And we have point O here for us. Let's look at the point L. Let's see here. 1, 2, 3. We're at -3 on the x-axis. And we're 1, 2, 3, 4, 5, 6 on the y-axis. And we'll look at the at point M here. He is at 2, 2. And we're going to use those 2 points to determine the length of LM. So that's going to be -3 minus 2 squared plus 6 minus 2 squared. And then we're going to look at OL, the length of OL, and that's going to be 8, that's a parenthesis, minus a -3. Oh, wait a minute, that's a -8. There. -8 minus 3 squared plus 2 minus 6 squared. All right, go ahead and pause the video and walk through those two distances in your calculator. Make sure that you and I agree. Again, pause the video and come back and take a look. All right, and so you should have gotten that LM was about 6.4 and that OL is about 6.4. And so since LM is congruent to OL, then we absolutely not only have a parallelogram on our hand, but we actually have a rhombus. So if I were to ask you this type of question, I probably would kind of go here and then take it another step and say, hey, what else is going on here? Is it a rectangle in addition? Is it a rhombus? That kind of thing. All right, there's a U-try down here I'm going to have you guys work through. And the question in this case is looking for a fourth quadrant coordinate to create a parallelogram. So let's just go ahead and highlight our fourth quadrant. Okay, and we know that that fourth point is going to be somewhere in this area. So you can go ahead and draw a line from L to N and a line from L to M. And you want to walk yourself through that same process. Whatever you do to go from L to M, you're going to do the same thing from N to M, or rather, sorry, N to the new point. Again, we'll call that point O. Just kind of dump it back down there. And then determine, number 1, the slopes of the opposite sides. Make sure the slopes of the opposite sides are the same. To confirm you have a question mark. And then you want to look at the slopes of the adjacent sides. Is it a rectangle? That would help us determine if it's a rectangle. This is, the first part is parallelogram. And then finally, we're going to look at the distance or the length of the adjacent sides to confirm we've got a rhombus or not. So lengths of adjacent sides. And the final thing I want you to confirm is exactly what type of quad do you have? Is it a parallelogram? Is it a rectangle? Is it a rhombus? Or is it all the way a square based on what we know? All right, pause the video and work through this problem. And when you've finished, check your work. All right, and you should have gotten the fact that the opposite slopes are, or rather going from L to M, I did the same thing from N to O using the slope of -4/5. Came up with a point O in the fourth quadrant at 2, -6. So this would be the point that gets us a parallelogram. And then when I walk through the number 2, which was slopes of adjacent sides, I can see that I've got an undefined slope for this other side, so there's definitely not a parallel relationship, I'm sorry, a perpendicular relationship. And then on 3, the adjacent lengths, one is worth 8 and one is 6.4. So this is nothing more than a parallelogram. Finally, we have, can you prove this figure is not a parallelogram? Well, we can look at it and see that this line SR and this line PQ are definitely not parallel lines. Eventually they're going to hit each other. So yeah, you would just confirm, whoops, yes, you would confirm opposite slopes, not congruent.